The Indian Space Research Organization or ISRO receives Indo-US developed NISAR satellite. The US Air Force handed over NISAR, an Earth observation satellite jointly developed by NASA and ISRO, to the Indian Space Agency. The satellite is an outcome of a collaboration between the American Space Agency NASA and ISRO. The satellite is expected to be launched in 2024 from Satish Dhawan Space Center in Andhra Pradesh into a near-polar orbit. What is NISAR? The NASA-ISRO Synthetic Aperture Radar or NISAR is a joint Earth-observing mission between NASA and ISRO, developed with the goal to make global measurements of the causes and consequences of land surface changes using advanced radar imaging. On September 30, 2014, NASA and ISRO signed a partnership to collaborate on and launch NISAR. The NISAR satellite is designed to observe and take measurements of some of the planet's most complex processes. These include ecosystem disturbances, ice sheet collapse, and natural hazards such as earthquakes, tsunamis, volcanoes, and landslides. What are the applications of NISAR? NISAR is the first satellite mission to collect radar data in two microwave bandwidth regions called the L band and the S band to measure changes in our planet's surface less than a centimeter across. This allows the mission to observe a wide range of Earth processes, from the flow rates of glaciers and ice sheets to the dynamics of earthquakes and volcanoes. NASA is providing the mission's L-band synthetic aperture radar, a high-rate communication subsystem for science data, GPS receivers, a solid-state recorder, and payload data system. ISRO is providing the spacecraft bus, the S-band radar, the launch vehicle, and associated launch services. NISAR uses a sophisticated information processing technique known as synthetic aperture radar to produce extremely high-resolution images. Radar penetrates clouds and darkness, enabling NISAR to collect data day and night in any weather. NISAR will add a tremendous new data set and greatly improve upon existing applications. By virtue of the planned, frequent and regular sampling of some of the world's most hazard-prone areas, these data will be a rich source of information to guide development of applications and their associated scientific studies. It will be a reliable data source over the life of the mission for proactive planning for disasters and will have a store of pre-disaster images available to rapidly understand what transpired in the disaster, leading to the development of actionable applications that could inform the government for consideration of future operational missions. Water resource monitoring, infrastructure monitoring, and other value-added applications will also be revolutionized by access to these data. Over the course of multiple orbits, the radar images will allow users to track changes in croplands and hazard sites, as well as to monitor ongoing crises such as volcanic eruptions. The images will be detailed enough to show local changes and broad enough to measure regional trends. As the mission continues for years, the data will allow for better understanding of the causes and consequences of land surface changes, increasing our ability to manage resources and prepare for and cope with global change. To know more about synthetic aperture radar, click the link in the description.